Good morning. Welcome to video lecturing class on for the subject control engineering. So today we'll start with the second bit in the second model. So the first bit was mathematical modeling of physical systems, electrical systems, thermal systems, and pneumatic systems. So here we'll start with the block diagrams and signal flow graphs. In that, first we'll start with the block diagrams. So the basic definition is it is a pictorial representation of functions performed by each component and also flow of signals. The diagram shows the interrelationship between various elements in the system. So basically, if you take a system, it is made up of several elements, right? So you can call it as an assembly. So each element in a system is having a different function. So the ultimate aim is to get the proper output. If any variations in any of the element or the function of any of the element, the output will deviate from the desired one. Okay. So these block diagrams will help us to analyze the functions of each and every element in the system. Okay. So otherwise, if you go with the theoretical analysis, you need to write the differential equations for each and every element. Okay. So we will be having number of differential equations. If they are of the second or third order differential equation, it will be simple to understand, but if it is of the higher order differential equation, at that time it is very difficult to understand the behavior of the system. So by using these block diagrams, easily you can analyze the function of each and every element to get the desired output. If you want to change any functions or any parameter in a particular element, so by with the help of these block diagrams, you can analyze the effect of the change which you want to impart in this system. Okay. So in block diagram, the interconnection of system components to form a system can conveniently shown by the blocks arranged in a proper sequence. So it explains cause and effect relationship existing between input and output of the system through the blocks. So these are some of the advantages of the block diagram. It is very simple to construct the block diagram for, even though the system is complicated, the function of individual element can be visualized from the block diagram. As I explained earlier, you can analyze or visualize the function of each and every element in the system. Individual and overall performance of this system can be studied by using the transfer function. Ultimately, we are going to have only one transfer function. So by analyzing or by studying that transfer function, we can understand or we can study the overall performance of the system. And the fourth one is overall closed loop transfer function can be easily calculated by using block diagram reduction rules. So even though you are representing each and every element with the individual blocks, at the end you can reduce all the blocks into a single block diagram, that is one input block diagram and output one block. So in that block we are going to write the transfer function. And disadvantages: block diagram does not include any information about the physical construction of the system. It is only functional based, not the physical based. Second one is source of energy is generally not shown in the block diagram. So number of different block diagrams can be drawn depending upon the point of view of the analysis. So block diagram for a given system is not in. So for example, if I want to represent a system with the help of block diagram, so my point of view may be different, because in this block diagram we are not going to show the source of the input. Okay. So you can draw with the different type of the block diagram for a single system. It depends upon the analyzer. Then the next one is, there are some rules to reduce the block diagram into a single block diagram. So the very first one is associative law. if two summing points are connected in series, then the incoming signals can be interchanged. So this is the first initial condition. These are the summing points. If they are connected in series, that is, there is no block between them or there is no takeoff between them, that time if you interchange these signal of these two summing points, your output remains same. For example, here R1 is the input, R2 is with negative sign, so the signal which is coming from this summing point will be R1 minus R2, and here R3 is input signal. So put together your output will be R1 minus R2 plus R3. If I interchange these two signals, that is R3 here, R2 here with sign, then R1 is here, R3 is here. So here it will be R1 plus R3 and R2 is here. So R4 will be R1 plus R3 minus R2, which is equal to this. So if there is no if there is no takeoff point or if there is no block between two summing points, that time you can interchange the signal of summing points. Then the second one is blocks in series, cascade connection. If there are two blocks which are connected directly, in between there is no takeoff or there is no summing point, so that time you can replace these two block diagrams with a single block diagram by writing the transfer function as product of their individual transfer function. So the transfer function of this block is G1 and for this it is G2. So the product or the resultant transfer function will be G1 into G2. So I will reduce these two, or I will replace these two blocks by a single block which is having the transfer function as G1 into G2. Remember, when you are applying this series rule, there should not be any intermediate things, that is, there should not be any summing point or there should not be any takeoff point. Then if there are blocks in parallel, that is end-to-end connection, can say it is starting point is same, ending point is same for the blocks, that time we can say that those blocks are in parallel combination. So we can reduce these blocks into a single block by writing their transfer function, by combining their transfer functions. So here it is G1, G2, G3. So output will be G1 plus G2 plus G3, right? Because all are with positive sign. So I can replace these three blocks by a single block by writing the transfer function as G1 plus G2 plus G3. Remember, here if it is G2 is fed with positive, G1 is fed with positive. If these G3 instead of a positive sign, if we fed with negative sign, that time here it will be G1 plus G2 minus G3 you have to write. Always you have to take care of these signs around the summing points. Then the fourth one is shifting of a summing point behind the block. In some cases, for the simplification purpose or to reduce the block diagram, it is necessary. Sometimes you need to shift the summing point. So in that case, if I want to shift this summing point before this block, okay, so that time what will happen, we'll see. So here R of S is the input, G, it will be G R into G plus G of S, and plus Y is fed here, so your output will be RG plus Y. If I shift this summing point before the block, that time it will be R of S plus X into G will be the output, but output should remain same. If you shift or if you apply any rule, your output should remain same. So to keep output same after shifting, we'll equate these two. So RG plus Y equal to RA plus X into G. So where Y equal to X into G or X equal to Y into 1 by G. That is, the signal Y should be multiplied by 1 by G. Then only you will get the same output. So whenever you are shifting a summing point before any block, that time to this signal you need to divide the signal by the transfer function of this block, that is 1 by G. So here it will be y into 1 by g, y by g will be there, this will be r, so it will be r plus 1 by g will be the output, and it is multiplied with g, so the output will be rg plus y. Similarly, the next one is shifting of summing point beyond the block or ahead of the block. So in previous case shifted before the block, now will shift after the block. If this summing point is here, if I want to shift this summing point after this block, that time, so first when it was before the block, that time the output is r plus y into g is the output. If I shift here, that time it will be g plus x, sorry, r into g plus x, but output should remain same. For that, equate these two, you will get x as y into g. That means whenever you are shifting a summing point after the block or beyond the block or ahead of the block, that time to this signal you need to multiply with the transfer function of this block, that is y into g. So it will be r into g and it is y into g, so it will be r plus y into g will be the output. Then the next one is shifting of takeoff point behind the block. So this is the takeoff point. Takeoff point is nothing but it is a signal which is fed to the feedback element. So here it is not a part of this, it is a whole signal itself. Okay, so the value of this C of S and this Y will be same. So when it is coming from here, that time its value will be R into G, right? R into G. When you shift this takeoff point before the block, that is I will replace it by X. So that time here it is having only R. Okay, but to keep the takeoff signal value same, what do we have to do? We need to multiply this X with G. Okay. So add a block whose transfer function is same as that of this block when you are shifting before the block, multiply with G. Okay. Then the opposite condition, that is shifting of takeoff point beyond the block, that is ahead of the block. So here the value is only y. When you shift here, it will be rg, because r into g is fed it's the output. So to keep the takeoff point value same, you need to divide the signal by by g. Okay, so r into g, here it should be multiplied with 1 by g. So here if you observe the shifting of takeoff and shifting of summing point, they are same but in reverse condition, vice versa. Okay, that is when you are shifting a takeoff point behind the block, that time you are multiplying the signal, or you are multiplying with the transfer function. Similarly, when you are shifting the summing point behind the block, that time you are dividing. Just remember these conditions, that is when to multiply and when to divide for any one of the element, that is either for summing point or for takeoff point. Then vice versa you can use. Then the next one is 8th rule is shifting of takeoff point beyond the summing point. When there are two elements, that is summing point and takeoff point. So if I want to shift this takeoff point after this block, so that time initially its value is r, the value of x is, the signal is r, but when you shift here it will become z, that is r plus or minus y will be the z value, but the value of that takeoff should remain same, that it should remain as r only. So to keep this z value as r, I have to subtract and add minus or plus y to this one. So for that you have to add one more summing point here with opposite signals. For example, here I have shown both the sign. If it is plus, that time it should be minus. If it is minus, that time it should be plus. Then only your output will be same, because here it is r into plus or minus y z value, and here this x value will be r into plus or minus y minus or plus y will be r only. Similarly, shifting of takeoff point behind the summing point. So if I want to shift this one behind the summing point, so that time also here it is r plus or minus y, but when you shift this takeoff behind the summing point, so the 10th rule is canonical form. So here canonical means when there are only two blocks, one summing point and one takeoff point. Okay, so in those two, one is in forward path and one is in feedback path. So g of s, this block is in forward, this block is in backward. So in the block diagram, if you are having this kind of combination, that time directly you can write the transfer function. That is, directly you can replace this whole system by a single block. So to derive that one, so from this figure, E of s is equal to R of s minus or plus B of s. B of s is C of s into H of s, because it is a signal which is coming from the takeoff. C of s into H of s, and C of s is E of s into G of s. So substituting this equation number 3 in 1, we'll get E of s as this one, and from equation number 3 we'll get the value of E of s. So C of s divided by G of s will be R of s plus minus or plus C of s into H of s. Now simplify this to get the transfer function. So transfer function is the ratio of output by input. Output is C of s and input is R of s, will be equal to G of s divided by 1 plus or minus G of s into H of s. So this is the transfer function for a single block. So here whenever you come across this kind of combination, that time directly you can write the single transfer function, that is in the numerator this g divided by in the denominator 1. If here it is minus, you have to write plus. If here it is plus, you have to write it minus 1 plus or minus this into this you have to write. So you can replace the whole system by a single block. So to solve the problems, you need to remember all these 10 rules. So we'll start with the first problem. So here he has given the block diagram to reduce it and to get the overall transfer function. So the first step is you need to check for the series or parallel combination. So since there are no series combination or no parallel combination, series means there should not be any takeoff or summing point between two blocks. If I take G1 and G2 as reference blocks, here in between you are having a summing point, so you cannot take these combination as series combination. Similarly, cannot take G3 and G4 because in between there is a takeoff point. So now to simplify this, shift the takeoff point towards the right side, that is beyond the block, then H2 is multiplied with 1 by G4. Okay, so I will shift this takeoff point after the block. So whenever you are shifting the takeoff point after the block, you have to remember those rules. When you are shifting the takeoff point after the block, that time you have to divide that signal by the transfer function, that is 1 by G4. That time this G3 and G4 will be in series combination. So I can replace these two blocks by a single block by writing the transfer function as G3 into G4, because when you shift here, this takeoff point here, they will become series. Okay, so now if you see the combination, this combination, it is forming a canonical loop or canonical form. So directly you can replace this by writing a single block diagram. So for that, in the numerator, this one G3 into G4 divided by 1. So here it is with minus sign. So opposite sign plus numerator into, sorry, this block into this block, that is G3, G4 into H3. Now if you take these two, again these two are in series. So whenever they are in series, you have to write the product. When you replace these two by a single block, that time again it will become a canonical loop with this block. So for that one you have to write the transfer function. So that time it will be in the numerator, will be having this divided by 1. Here it is with minus sign plus into this transfer function into this, that is G2, G3, G4 divided by this one into H2 by G4. So now this block and this block will form this series. Write the product. When you write the product, we are going to replace with the single block, and that block is going to make the canonical loop with this one. So directly you can write in the numerator this product divided by 1 plus here, because it is with minus sign, this term, that is this product, into this signal H1. So when you simplify that, you will get output as G1, G2, G3, G4 divided by 1 plus G3, G4, H3 plus G2, G3, H2 plus G1, G2, G3, G4, H1. So remember, while solving the problem, it is not mandatory that always you have to use the series rule first or parallel rule first, or you have to use only one rule at once. It is not like that. Just go for checking the combination, try to simplify. If it is a complicated one, that time try to shift the takeoff point or summing point, so that you always try to get the canonical loop, so that easily you can write the transfer function. So you first to go through all the rules, try to understand how to simplify or how to use those rules and when to use those rules. Then you try to solve this problem. Okay, so we will understand where you can face the difficulties. And one more thing, this is not only the solution for this problem. Okay, so here in the first step, I have shifted this takeoff point here. Okay, so this is one of the simple solution. Otherwise, what I can do, I will shift this summing point here, then I will take these series, then I will interchange these signs. There are n number of ways to solve the problem, but try to solve the problem in a simple way, so that if you are going to shift here, again you need to do some changes to this one, then you need to interchange these signals. It will be difficult. So first try to understand the given problem and try to look for any series or parallel combination are there. If there is no parallel or series combination, then only you go for shifting of the takeoff or summing point. And while using those rules also, make sure that just by one shift you will get the canonical loop at least for the remaining blocks, so that it will be easy to simplify the problem. So if you have any doubt, you can leave a comment in the comment box to go through these problems. So in the next lecture, we'll try to solve some of the complicated problems, so that you can understand the rules in a better way. Thank you.